Dynamic Systems Development Method is an agile project delivery framework, primarily used as a software development method. First released in 1994, DSDM originally sought to provide some discipline to the rapid application development method. In 2007, DSDM became a generic approach to project management and solution delivery. DSDM is an iterative and incremental approach that embraces principles of agile development, including continuous user-customer involvement. DSDM fixes cost, quality and time at the outset and uses the Moscow prioritization of scope into musts, shoulds, coulds and won't-haves to adjust the project deliverable to meet the stated time constraint. DSDM is one of a number of agile methods for developing software and non-IT solutions, and it forms a part of the Agile Alliance. In 2007, DSDM was rebranded DSDM Autern. The name Autern was a shortening of Arctic tern, a collaborative bird that can travel vast distances and epitomizes many facets of the method which are natural ways of working, for example prioritization and collaboration. In 2014, DSDM dropped the branding Autern and reverted to its original name in the latest version of the method in the DSDM Agile Project Framework, positioned as an ideal wrapper for more limited Agile frameworks. DSDM is often used to provide the full project focus to complement Scrum's team-focused product development process. At the same time, the new DSDM manual recognized the need to operate alongside other frameworks for service delivery, Prince2, managing successful programs, and PMI-BOK. The previous version had only contained guidance on how to use DSDM with extreme programming. DSDM and the DSDM Consortium, Origins. In the early 1990s, rapid application development was spreading across the IT industry. The user interfaces for software applications were moving from the old green screens to the graphical user interfaces that are used today. New application development tools were coming on the market, such as Power Builder. These enabled developers to share their proposed solutions much more easily with their customers. Prototyping became a reality and the frustrations of the classical, sequential development methods could be put to one side. However, the RAD movement was very unstructured, there was no commonly agreed definition of a suitable process and many organizations came up with their own definition and approach. Many major corporations were very interested in the possibilities, but they were also concerned that they did not lose the level of quality in the end deliverables that free-flow development could give rise to. The DSDM Consortium was founded in 1994 by an association of vendors and experts in the field of software engineering and was created with the objective of jointly developing and promoting an independent RAD framework by combining their best practice experiences. The Origins were an event organized by the Butler Group in London. People at the meeting all worked for blue-chip organizations such as British Airways, American Express, Oracle and Logica. At the initial meeting it was decided that Jennifer Stapleton, then of Logica, would put together an architecture for an end-to-end, user-centric but quality-controlled method for iterative and incremental development. The resulting architecture was designed to be fully compatible with ISO 9000 and Prince2, which were two major concerns for the group. Once the architecture was in place, the consortium formed various task groups to populate it with all aspects of software development, including project management tools and techniques, quality and testing, development tools and techniques, personnel and software procurement. An oversight group led by the architect and consisting of the chairs of the task groups ensured consistency of the approach as it was developed. Although many of the consortium members were direct business competitors, they shared freely how they had addressed the various aspects. Best practice was extracted and formed into a cohesive whole. As the consortium grew in its first year from a handful of organizations to 60, the content of the method became increasingly robust. Version 1 was baselined in December 1994 and published in February 1995. The result was a generic method covering people, process and tools that was formed from the experiences of organizations of all sectors and sizes. The DSDM Consortium is a not-for-profit, vendor-independent organization which owns and administers the DSDM framework. DSDM Autern, Outturn is a vendor-independent approach that recognizes that more projects fail because of people problems than technology. Outturn, a unregistered trademark, focuses on helping people to work effectively together to achieve the business goals. Outturn is also independent of tools and techniques, enabling it to be used in any business and technical environment without tying the business to a particular vendor. Overview of DSDM. Outturn, as an extension of rapid application development, DSDM focuses on information systems projects that are characterized by tight schedules and budgets. DSDM addresses the most common failures of information systems projects, including exceeding budgets, missing deadlines, and lack of user involvement and top management commitment. In 2007, a team set up by the DSDM consortium looked into the content of DSDM v4.2 and decided that the underlying mechanics and structure were completely sound, but that the terminology and the focus purely on IT applications should be updated to meet the needs of projects in the new millennium. Some of the content of the method had been there since 1995. The new version was launched at the Café Royal in London on April 24, 2007. Some amendments were made in April 2008 and incorporated in the latest version of the Outturn Handbook. The DSDM Outturn approach, principles. There are 8 principles underpinning DSDM Outturn. These principles direct the team in the attitude they must take and the mindset they must adopt in order to deliver consistently. 1. Focus on the business need. The main criteria for acceptance of a deliverable is delivering a system that addresses the current business needs. Delivering a perfect system which addresses all possible business needs is less important than focusing on critical functionalities. Clearly define the scope of the system, understand the true business priorities, establish a sound business case, seek continuous business sponsorship and commitment, guarantee the minimum usable subset of features. 2. Deliver on time. Timebox the work, focus on business priorities, always meet deadlines. 3. Collaborate. User involvement is the main key in running an efficient and effective project, where both users and developers share a workplace, so that the decisions can be made collaboratively and quickly. Involve the right stakeholders, at the right time, throughout the project. Ensure that the members of the team are empowered to take decisions on behalf of those they represent without waiting for higher-level approval. Actively involve the business representatives, build one team culture. 4. Never compromise quality. Set the level of quality at the outset, ensure that quality does not become a variable, design, document and test appropriately, build in quality by constant review, test early and continuously. See test-driven development for comparison. 5. Build incrementally from firm foundations. Strive for early delivery of business benefit where possible, continually confirm the correct solution is being built, formally reassess priorities and ongoing project viability with each delivered increment. 6. Develop iteratively, focus on frequent delivery of products, with assumption that to deliver something good enough earlier is always better than to deliver everything perfectly in the end. By delivering product frequently from an early stage of the project can be tested and reviewed where the test record and review document can be taken into account at the next iteration or phase. Do enough design upfront to create strong foundations, take an iterative approach to building all products, build customer feedback into each iteration to converge on an effective business solution. Accept that most detail emerges later rather than sooner, embrace change. The right solution will not evolve without it, be creative, experiment, learn, evolve. 7. Communicate continuously and clearly. Communication and cooperation among all project stakeholders is required to be efficient and effective. Run daily team stand-up sessions, use facilitated workshops, use rich communication techniques such as modeling and prototyping, present iterations of the evolving solution early and often, keep documentation lean and timely, manage stakeholder expectations throughout the project, encourage informal, face-to-face communication at all levels. 8. Demonstrate control. Use an appropriate level of formality for tracking and reporting, make plans and progress visible to all, measure progress through focus on delivery of products rather than completed activities, manage proactively, evaluate continuing project viability based on the business objectives. Prerequisites for using DSDM. In order for DSDM to be a success, there are 9 instrumental factors which need to be met. If these cannot be met, it presents a risk to the outturn approach, which is not necessarily a showstopper but which does need to be managed. These risks are also highlighted by the project approach questionnaire. Acceptance of the outturn philosophy before starting work. Appropriate empowerment of the solution development team. Commitment of senior business management to provide the necessary business ambassador involvement. Incremental delivery, access by the solution development team to business roles, solution development team stability. Solution development team skills. Solution development team size. A supportive commercial relationship. DSDM 4.2, overview of DSDM version 4.2, as an extension of rapid application development, DSDM focuses on information systems projects that are characterized by tight schedules and budgets. DSDM addresses the most common failures of information systems projects, including exceeding budgets, missing deadlines, and lack of user involvement and top management commitment. By encouraging the use of RAD, however, careless adoption of DSDM may increase the risk of cutting too many corners. DSDM consists of 3 phases: pre-project phase, project lifecycle phase, and post-project phase. A project lifecycle phase is subdivided into 5 stages: feasibility study, business study, functional model iteration, design and build iteration, and implementation. In some circumstances, there are possibilities to integrate practices from other methodologies, such as rational unified process, extreme programming, and PRINCE2, as complements to DSDM. Another Agile method that has some similarity in process and concept to DSDM is Scrum. In July 2006, DSDM public version 4.2 was made available for individuals to view and use. However, anyone reselling DSDM must still be a member of the not-for-profit consortium. DSDM v4.2 Project Lifecycle Overview are 3 phases of DSDM v4.2. The DSDM framework consists of 3 sequential phases, namely the pre-project, project lifecycle and post-project phases. The project phase of DSDM is the most elaborate of the 3 phases. The project lifecycle phase consists of 5 stages that form an iterative step-by-step approach in developing an IS. The 3 phases and corresponding stages are explained extensively in the subsequent sections. For each stage phase, the most important activities are addressed and the deliverables are mentioned. Phase 1, the pre-projector. In the pre-project phase, candidate projects are identified, project funding is realized and project commitment is ensured. Handling these issues at an early stage avoids problems at later stages of the project. Phase 2, the project lifecycle layer. The process overview in the figure below shows the project lifecycle of this phase of DSDM. It depicts the 5 stages a project will have to go through to create an implemented system. The first 2 stages, the feasibility study and business study, are sequential phases that complement to each other. After these phases have been concluded, the system is developed iteratively and incrementally in the functional model iteration, design and build iteration and implementation stages. The iterative and incremental nature of DSDM will be addressed further in a later section. Phase 3, post-projector. The post-project phase ensures the system operates effectively and efficiently. This is realized by maintenance, enhancements and fixes according to DSDM principles. The maintenance can be viewed as continuing development based on the iterative and incremental nature of DSDM. Instead of finishing the project in one cycle, usually the project can return to the previous phases or stages so that the previous step and the deliverable products can be refined. Below is the process data diagram of DSDM as a whole project lifecycle with all of its 4 steps. This diagram depicts the DSDM iterative development, started on functional model iteration, design and build iteration, and implementation phase. The description of each stage will be explained later in this entry. 4 steps of the DSDM v4.2 project lifecycle, 4 stages of the DSDM v4.2 project lifecycle. Stage 1A, the feasibility study. During this stage of the project, the feasibility of the project for the use of DSDM is examined. Prerequisites for the use of DSDM are addressed by answering questions like, can this project meet the required business needs? Unregistered trademark, is this project suited for the use of DSDM? Unregistered trademark and what are the most important risks involved? Unregistered trademark. The most important techniques used in this phase are the workshops. The deliverables for this stage are the feasibility report and the feasibility prototype that address the feasibility of the project at hand. It is extended with a global outline plan for the rest of the project and a risk log that identifies the most important risks for the project. Stage 1B, the business study. The business study extends the feasibility study. After the project has been deemed feasible for the use of DSDM, this stage examines the influenced business processes, user groups involved and their respective needs and wishes. Again, the workshops are one of the most valuable techniques, workshops in which the different stakeholders come together to discuss the proposed system. The information from these sessions is combined into a requirements list. An important property of the requirements list is the fact that the requirements are prioritized. These requirements are prioritized using the Moscow approach. Based on this prioritization, a development plan is constructed as a guideline for the rest of the project. An important project technique used in the development of this plan is time boxing. This technique is essential in realizing the goals of DSDM, namely being on time and on budget, guaranteeing the desired quality. A system architecture is another aid to guide the development of the IS. The deliverables for this stage are a business area definition that describes the context of the project within the company, a system architecture definition that provides an initial global architecture of the IS under development together with a development plan that outlines the most important steps in the development process. At the base of these last two documents there is the prioritized requirements list. This list states all the requirements for the system, organized according to the Moscow principle. And last, the risk log is updated with the facts that have been identified during this phase of DSDM. Stage 2, Functional Model Iteration. The requirements that have been identified in the previous stages are converted to a functional model. This model consists of both a functioning prototype and models. Prototyping is one of the key project techniques within this stage that helps to realize good user involvement throughout the project. The developed prototype is reviewed by different user groups. In order to assure quality, testing is implemented throughout every iteration of DSDM. An important part of testing is realized in the functional model iteration. The functional model can be subdivided into 4 substages: identify functional prototype, determine the functionalities to be implemented in the prototype that results from this iteration. Agree schedule, agree on how and when to develop these functionalities. Create functional prototype, develop the prototype. Investigate, refine, and consolidate it with the combined functional prototype of previous iterations. Review prototype, check the correctness of the developed prototype. This can be done via testing by end user. Then use the test records and user unregistered trademark S feedbacks to generate the functional prototyping review document. The deliverables for this stage are a functional model and a functional prototype that together represent the functionalities that could be realized in this iteration, ready for testing by users. Next to this, the requirements list is updated, deleting the items that have been realized and rethinking the prioritization of the remaining requirements. The risk log is also updated by having risk analysis of further development after reviewing the prototyping document. Stage 3, System Design and Build Iteration. The main focus of this DSDM iteration is to integrate the functional components from the previous phase into one system that satisfies user needs. It also addresses the non-functional requirements that have been set for the IS. Again, testing is an important ongoing activity in this stage. The design and build iteration can be subdivided into 4 substages: identify design prototype, identify functional and non-functional requirements that need to be in the tested system. Agree schedule, agree on how and when to realize these requirements. Create design prototype, create a system that can safely be handed to end users for daily use. They investigate, refine, and consolidate the prototype of current iteration within prototyping process are also important in this substage. Review design prototype, check the correctness of the design system. Again, testing and reviewing are the main techniques used, since the test records and user unregistered trademark S feedbacks are important to generate the user documentation. The deliverables for this stage are a design prototype during the phase that end users get to test, and at the end of the design and build iteration the tested system is handed over to the next phase. In this stage, the system is mainly built where the design and functions are consolidated and integrated in a prototype. Another deliverable for this stage is a user documentation. Stage 4, Implementation. In the implementation stage, the tested system including user documentation is delivered to the users and training of future users is realized. The system to be delivered has been reviewed to include the requirements that have been set in the beginning stages of the project. The implementation stage can be subdivided into 4 substages: user approval and guidelines. End users approve the tested system for implementation, and guidelines with respect to the implementation and use of the system are created. Train users, train future end user in the use of the system. Implement the tested system at the location of the end users. Review business, review the impact of the implemented system on the business. A central issue will be whether the system meets the goals set at the beginning of the project. Depending on this, the project goes to the next phase, the post-project, or loops back to 1. DSDM v4.2 Functional Model Iteration, Metadata Model. The associations between concepts of deliverables in functional model iteration stage are depicted in the metadata model below. This metadata model will be combined with a meta-process diagram of functional model iteration phase in the next part. Process data model. Identify functional prototype activity is to identify the functionalities that would be in the prototype of current iteration. Recall that both analysis and coding are done. Prototypes are built, and the experiences gained from them are used in improving the analysis models. The built prototypes are not to be entirely discarded, but gradually steered towards such quality that they can be included in the final system. Agree schedule is to determine when and how the prototyping will be implemented. It extends the scope to the available timetable and prototyping plan. And since testing is implemented throughout the whole process, unregistered trademark S also an essential part of this phase, and therefore it is included in the review prototype activity right after the functional prototype is built, and the test record will eventually be used in the review prototype process and generates the review document. Below is the process data diagram of functional model iteration stage. Further DSDM v4.2 topics. Time boxing. Time boxing is one of the project techniques of DSDM. It is used to support the main goals of DSDM to realize the development of an is on time, within budget and with the desired quality. The main idea behind time boxing is to split up the project in portions, each with a fixed budget and a delivery date. For each portion, a number of requirements are selected that are prioritized according to the Moscow principle. Because time and budget are fixed, the only remaining variables are the requirements. So if a project is running out of time or money, the requirements with the lowest priority are omitted. This does not mean that an unfinished product is delivered, because of the Pareto principle that 80% of the project comes from 20% of the system requirements. So as long as those most important 20% of requirements are implemented into the system therefore meets the business needs, and that no system is built perfectly in the first try. Moscow represents a way of prioritizing items. In the context of DSDM, the Moscow technique is used to prioritize requirements. It is an acronym that stands for MUST. Have this requirement to meet the business needs. Should have this requirement if at all possible, but the project success does not rely on this. Could have this requirement if it does not affect the fitness of business needs of the project. won't represents a requirement that stakeholders have agreed will not be implemented in a given release, but may be considered for the future. Prototyping. This technique refers to the creation of prototypes of the system under development at an early stage of the project. It enables the early discovery of shortcomings in the system and allows future users to test drive a unregistered trademark the system. This way good user involvement is realized, one of the key success factors of DSDM, or any system development project for that matter. Testing. A third important aspect of the goal of DSDM is the creation of an is with good quality. In order to realize a solution of good quality, DSDM advocates testing throughout each iteration. Since DSDM is a tool and technique-independent method, the project team is free to choose its own test management method, for example test management approach, workshop, one of DSDM a unregistered trademark as project techniques that aims at bringing the different stakeholders of the project together to discuss requirements, functionalities and mutual understanding. In a workshop the stakeholders come together and discuss the project. Modeling. This technique is essential and purposely used to visualize the diagrammatic representation of a specific aspect of the system or business area that is being developed. Modeling gives a better understanding for DSDM project team over a business domain. Configuration management. A good implementation of this configuration management technique is important for the dynamic nature of DSDM. Since there is more than one thing being handled at once during the development process of the system, and the products are being delivered frequently at a very fast rate, the products therefore need to be controlled strictly as they achieve completion. There are some roles introduced within DSDM environment. It is important that the project members need to be appointed to different roles before they start to run the project. Each role has its own responsibility. The roles are: executive sponsor, so-called the A-OE project champion Euro. An important role from the user organization who has the ability and responsibility to commit appropriate funds and resources. This role has an ultimate power to make decisions. Visionary, the one who has the responsibility to initialize the project by ensuring that essential requirements are found early on. Visionary has the most accurate perception of the business objectives of the system and the project. Another task is to supervise and keep the development process on the right track. Ambassador user brings the knowledge of user community into the project, ensures that the developers receive enough amount of user or unregistered trademark as feedbacks during the development process. Advisor user can be any user that represents an important viewpoint and brings the daily knowledge of the project. Project manager can be anyone from user community or IT staff who manages the project in general. Technical coordinator, responsible in designing the system architecture and control the technical quality in the project. Team leader leads his team and ensures that the team works effectively as a whole. Solution developer interpret the system requirements and model it, including developing the deliverable codes and builder prototypes. Solution tester checks the correctness in a technical extent by performing some testings, raise defects where necessary and retest once fixed. Tester will have to give some comments and documentation. Scribe responsible to gather and record the requirements, agreements, and decisions made in every workshop. Facilitator responsible in managing the workshop's progress, acts as a motor for preparation and communication. Specialist roles: business architect, quality manager, system integrator, etc. Next to time boxing and prioritizing of requirements, the DSDM also provides an iterative and incremental approach to its development. This can be seen in the figure depicting the process overview above. The functional model iteration, design and build iteration and implementation stages can go over their sub-stages several times before entering the next stage. Each iteration addresses a set of new functionalities, and every iteration builds on a working predecessor. Each iteration can be undone if needed. The process overview figure also shows arrows going back to previous stages. For example, there is an arrow from implementation to the business study. If a big functionality has been discovered during development that couldn't a unregistered trademark be implemented, it might be possible to start all over by defining new requirements in a business study. Similarly, there is an arrow from implementation to the functional model iteration. Functionality might be omitted during a previous functional model iteration because of time or budget constraints. The project should proceed into the post-project phase only when it meets all the requirements defined by the project and business goals. Because of the iterative nature of DSDM, it is essential to maintain good requirements management and configuration management throughout the entire project. This ensures that the project does implement the requirements that were decided in the early phases of the project. Meta-model, as explained in the Wikipedia item, meta-modeling takes a higher-level look at methods and techniques. In doing so, it offers possibilities for comparing similar methods and techniques and engineering new methods from existing ones. The metadata model, depicted above, identifies the concepts and associations between these concepts within DSDM. As can be seen from the figure, two main concepts can be identified, namely the phase and the flow concept. Each flow originates from a phase within DSDM. Flows can be divided up in the sub-concepts data and product. This subdivision is denoted with a C, which means that the subdivision is disjoint and complete. In other words, a flow is always either a data flow or a product flow, but never both. In the situation of DSDM, a data flow can be an arc returning to one of the preceding phases. Product flows are tangible goods that result from one of the phases and are the input of the next phase, for example reports and prototypes. Then there is the second concept phase that is also be divided to sub-concepts with a complete and disjoint ordering. These sub-concepts are the sequential and the iterative phases. As was explained in an earlier section, DSDM starts with two sequential phases, the feasibility and business study. Next, a number of iterative phases follow, that is functional model, design and build and implementation phases. The picture also mentions a number of rules and issues that are not included in the model, but that are important for this meta-model. First, there are the rules that concern the behavior of the a unregistered trademark flows a unregistered trademark a unregistered trademark. These rules restrict the freedom of the flow so that they correspond to the a unregistered trademark for C a unregistered trademark a unregistered trademark transitions within DSDM. Next to the rules, a number of important issues are addressed that ensure that the DSDM project lifecycle is guaranteed. Critical success factors of DSDM. Within DSDM, a number of factors are identified as being of great importance to ensure successful projects. Factor 1. First, there is the acceptance of DSDM by senior management and other employees. This ensures that the different actors of the project are motivated from the start and remain involved throughout the project. Factor 2. The second factor follows directly from this, and that is the commitment of management to ensure end-user involvement. The prototyping approach requires a strong and dedicated involvement by end-user to test and judge the functional prototypes. Factor 3, then there is the project team. This team has to be composed of skillful members that form a stable union. An important issue is the empowerment of the project team. This means that the team has to possess the power and possibility to make important decisions regarding the project without having to write formal proposals to higher management, which can be very time-consuming. In order for the project team to be able to run a successful project, they also need the right technology to conduct the project. This means a development environment, project management tools, etc. Factor 4. Finally, DSDM also states that a supportive relationship between customer and vendor is required. This goes for both projects that are realized internally within companies or by outside contractors. An aid in ensuring a supporting relationship could be ISPL. Comparison to other development methods. Over the years, a great number of information system development methods have been developed and applied, divided in structured methods, RAD methods and object-oriented methods. Many of these methods show similarities to each other and also to DSDM. For example, Extreme Programming, XP, also has an iterative approach to its development with extensive user involvement. The Rational Unified Process is a method that probably has the most in common with DSDM in that it is also a dynamic form of information system development. Again, the iterative approach is used in this development method. Like XP and RUP, there are many other development methods that show similarities to DSDM, but DSDM does distinguish itself from these methods in a number of ways. First, there is the fact that it provides a tool and technique-independent framework. This allows users to fill in the specific steps of the process with their own techniques and software aids of choice. Another unique feature is the fact that the variables in the development are not time resources, but the requirements. This approach ensures the main goals of DSDM, namely to stay within the deadline and the budget. And last, there is the strong focus on communication between and the involvement of all the stakeholders in the system. Although this is addressed in other methods, DSDM strongly believes in commitment to the project to ensure a successful outcome. See also, Agile software development, extreme programming, lean software development, iterative and incremental development, Moscow method, IBM rational unified process, rapid application development, Pareto principle, PRINCE2, Scrum, structured systems analysis and design method. References. Further reading, Coleman and Verbruggen, A Quality Software Process for Rapid Application Development, Software Quality Journal 7, PA 107-1222, Ben & Davis and Williams, The Diffusion of Information Systems Development Methods. Journal of Strategic Information Systems 12 PA 29-46, Stjijk Brinkemper, Saki and Harmsen, Assembly Techniques for Method Engineering, Advanced Information Systems Engineering, Proceedings of CAIC 98, Springer Verlag, Abrahamson, Salo, 1 Kanin, Worcester Agile Software Development Methods, Review and Analysis, VTT Publications 478, PA 61-68, Tufts, Stapleton, West, Eason. Interoperability of DSDM with the Rational Unified Process, DSDM Consortium, Issue 1, PA 1-29, Riepman, DSDM in a Bird Unregistered Trademark SI View, DSDM Consortium, PA 3-8, ISDLC Integrated Systems Development Lifecycle, Keith Richards, Agile Project Management, Running PRINCE2 Projects with DSDM or TAN, TSO, DSDM Handbook, DSDM Agile Project Management Framework Interactive Mind Map, External links, the DSDM Consortium.